So let's take a look here now at example 5. We're going to try to do the same sort of basic approach that we took when we looked at example 4. So I'll see right away here that if I try to evaluate this limit, I'm going to get that my x is going to be moving towards negative infinity, and e to the x. I should know a graph of what e to the x looks like. Again, it's one of our graphs to know. So I can see that if this is the graph of e to the x, if I approach negative infinity on the graph, that is, I'm moving to the left side as I'm on the path, then this value of e to the x is going to be moving towards 0. So again, I have negative infinity times 0, kind of like exactly what I had up here. And so again, this is an indeterminate form, but not one that I can use L'Hopital's rule with. So I'm going to have to think about a clever way to maybe rewrite this. Now, in the last video, we took a look at kind of doing an unsimplification. So I'm going to ask you to go ahead and pause the video here to see if you can try to do an unsimplification of what we have here, and see if you can try to arrive at an answer. Now, chances are you're going to get stuck, and that's okay. Give it a shot anyways, but just be aware that I'm telling you, you're probably going to get stuck. But then once you feel like you're sufficiently stuck, unpause the video and you'll see me work through the exact solution. Okay, well hopefully you actually did go ahead and try this out. Let's go ahead and probably take the approach that many of you took at the beginning. So chances are if you tried to kind of repeat what we did in the example up above, you said that if I had a limit as x goes towards negative infinity, and I got this x times e to the x, then you probably ended up rewriting this by doing e to the x over a 1 over x. A totally valid simplification. Nothing wrong with this. Now, if I try to go ahead and see what's going to be happening here, I'll recognize that my denominator goes to 0 and my top goes to 0, so I'm ready to use L'Hopital's rule. So this is looking perfect. But for those of you that took this approach, you'll recognize that it quickly starts to get really ugly really fast. Because the derivative of e to the x is just e to the x, and the derivative in our denominator is negative 1 over x squared. And I can see that, again, I'm going to have a form of 0 over 0. And so I could start thinking about taking L'Hopital's rule again and again and again if I wanted to, because there's no other way that I can really simplify this to make this any cleaner. But what gets really crazy is that even if I continue to use L'Hopital's rule here, I'm going to see that the numerator, or the numerator's derivative is always just e to the x, and in the denominator I'm just going to increasingly get more and more complicated things. And no matter how I simplify down here, I'm only ever going to get back to a form of a negative infinity times a 0. So this approach, while perfectly valid, just isn't helpful. And we'll see this a lot of times, and we have seen this a lot of times so far this semester. There are many things that we can do that are valid, but there are only some things we can do that are helpful. And so, okay, maybe this approach doesn't seem to be working, so we'll abandon it. So how about we say that instead, we will try, and I'm going to just try a different simplification or unsimplification here. I had e to the x, times an x. And so I'm going to go ahead and attempt to rewrite this in the following way. Instead of moving my x to the denominator, can't I move my e to the denominator just by making its power negative? I mean, technically we did the same thing down here and we wrote this as x to the negative first power. But now that I have this form, I can notice that my numerator is going to be going towards negative infinity. Notice down here, though, when I have x going towards negative infinity and x is made negative, that means I'm really having e to like a positive infinite power. That means I'm kind of reversing the direction. I'm going this way, and so I'm going to end up with infinity. Again, a nice indeterminate form. But the advantage here is that when I go ahead and I use L'Hopital's rule now, I can see that I'm going to end up with a derivative of 1 in the top and a derivative of negative e to the negative x in the denominator. I could, of course, go ahead and just rewrite this using some simple algebra and rewrite this as e to the x with just a negative in the front, just moving it back up to the top. And so I can see here that again, if I follow e to the x out towards negative infinity, I'm going to end up with 0. And so I get a final answer here of 0. Okay, so I can see here that maybe if one of the ways that I thought of simplifying isn't yielding anything, no big deal. Just try something else. We don't necessarily have to know how to solve every problem immediately. We just have to be able to tinker around with it enough. We have to be able to kind of think through it enough to just come up with a solution eventually. That's really the goal. And so what we're seeing here is that I shouldn't be too alarmed if my first simplification doesn't work. I might be able to try another one.